Do you really know where you are? You may say yes, but let me tell you that's not exactly true. The quantum world is made up of very small particles that behave like superheroes. Sometimes these particles behave like waves, or superheroes, while other times these particles behave like particles, or normal people. But at the end of the day, they are still the same particle or person. For example, if you release an electron across a room, it will travel in a wave-like format until it hits the wall at exactly one point, just like one particle. This phenomenon is known as wave-particle duality.
Each wave has a wavelength, which is the distance between two consecutive peaks or troughs on a wave. Famous scientist Louis de Broglie discovered a momentum can be calculated based on wavelength, but we cannot calculate the exact location of a wave because it could be here, or here, or here. Through the definition of a particle, we know that a particle exists at a single place at an instant in time. But since these particles do not have wavelengths, we cannot calculate their momentum. Since each of these particles behave like both a wave and a particle, we cannot be sure of both the particle's momentum and position at an instant in time. This is Heisenberg's uncertainty principle in a nutshell. If we are sure about the position of a particle, we cannot be 100% sure of its momentum, and vice versa. This principle can be demonstrated using light particles, or photons that have both particle and wave properties. The photons must pass through this opening. As the light on the wall spreads out more, we become more uncertain of the photon's momentum. The difference in each photon's momentum causes them to end up in different places. When the opening is wide, we are less sure of the photon's position, and the light is bunched up together, meaning we are more sure of the photon's momentum. As the opening narrows, we become more certain of the photon's position, but become less sure of the photon's momentum as the light spreads out, hence demonstrating Heisenberg's uncertainty principle.
Heisenberg's uncertainty principle serves as a foundation for quantum mechanics and limits our absolute understanding of the universe.